Okay, it's time to get going here. Sorry for starting a little bit late. The previous class was late getting out of here, so I wasn't able to start setting stuff up until a little bit later than normal. The day number one quiz, everyone received 5 points out of 5 points on it, unless you heard from me otherwise. So again, this is going to be part of the assignments and quizzes part of your overall grade for the course. Assignment number one, hopefully all of you saw my listserv post regarding that. Assignment number one, we will talk about about 1:20 today, and it is due September 9th at noon. Today we will finish up this intro section. We will spend especially some time talking about the set statement in a data step, because I think at the end of class last time I was going a little bit too fast over some stuff. I don't think I explained it very well, so we will make sure to talk about that. And then we'll get into the next section. Are there any questions before we begin? Okay, so we left off last time on approximately page 19 of my intro notes. And so what we're going to do is look at this data set that I call the cereal data, because it's based upon the nutritional content of a number of cereals. This is a nice data set that I collected a number of years ago. It's meant to be a simple data set, but can be used in a variety of ways to illustrate a number of different items. So I use it in a few of my classes because of it. Now, to help motivate this cereal data, that's not for our class. You can pick it up if you want, but it's not for our class. I just don't want you to be confused when the notes that you picked up there are probably different from what are up here. So anyway, to help motivate this, so this is a picture of a typical cereal aisle, dry cereal aisle that you will find at grocery stores. This picture is taken at the Hy-Vee at 27th and Superior here in Lincoln, before they renovated it about a year or two ago. So it doesn't look exactly like this anymore, but this is still typically what you often see at grocery stores. And if you notice here, we have 5 different shelves. So a lower shelf, let's call that shelf 1, all the way up to the highest shelf, let's call this shelf number 5. And you see boxes of cereal there. And so a number of years ago, I was curious about, well, I tend to see certain kinds of cereals on some shelves as opposed to others at grocery stores. And so to investigate this further, because it's kind of hard necessarily to group cereals certain ways, I decided, how about we look at the nutritional content of cereals. Specifically, I decided to focus on the sugar content, the fat content, and also the sodium content. And look at that for the cereals on these shelves. And so what I actually did, I didn't do it exactly at this store here. I did it at a different store. I took a stratified random sample of cereals from the shelves. Stratified based upon the shelf. So what that means is I randomly selected 10 cereals from the first shelf, the bottom one, went to the second shelf, randomly selected 10 cereals, and for every cereal I always kept track of the serving size, sugar content, sodium content, and fat content. And that became my data set. Now, some of my research hypothesis was, especially with regards to sugar, was that there would be differences among the shelves in the mean nutritional content. So for example, I hypothesized that the lower shelves would tend to have higher sugar content cereals than the higher shelves. Does anyone know why I would make that as my research hypothesis?
Kids see lower shelves while adults see higher shelves. Kids love sugar.
The kids love sugar, and it's typically the cereals that are marketed towards kids tend to have the higher sugar content cereals. Now, as a way to take some I guess, to find some empirical evidence for this. A few years ago, I decided to take my son, this is my son Cal, I took him shopping with me. My wife is behind the camera here. And this is at that same Hy-Vee that the original picture was taken from, but now on the right side you see all the cereals. And just interestingly, on the left side across from the cereals, Hy-Vee has toys. Interesting. And so this is Cal when he was about 2 years old. If you happen to see him at the stat department get together, he's 7 now. This is when he was about 2 years old, and he was really fascinated with Thomas the Tank Engine, if you've ever heard of that cartoon. And so right now he has happened to find there on the toy shelf a Thomas, and he's really happy about that. And if we just fast forward through here, let's see it very well.
No. This is what's across from the cereal aisle. Isn't that great? We're never going to get out of here.
What I do, and then next is I say, okay, Cal, I want you to go over to the cereals. And you can pick up some and put them into our cart. Of course, he was quite happy.
You want to get some Rice Krispies? Okay, we'll put them in here. You want some more?
Those look healthy.
Okay, last one.
See, it's the kids that are going to be able to see the lower shelves as we discussed earlier. And so I was curious are these higher sugar content cereals, do they tend to be on the lower shelves? And so here's what my actual data set looks like. Again, it was from a different it's from a different store. They only had 4 shelves. But so in my random sample, the first item that I obtained was from shelf 1. It was Kellogg's Razzle Dazzle Rice Krispies. 28 grams was serving size, 10 grams of sugar, so 10 of that is sugar content, 0 grams of fat, 170 milligrams of sodium. And so this is the whole data set. Here is a sample size of 40. And so what we're going to do now, and throughout the rest of the semester, we will look at this data set a little bit more further. We're not necessarily going to get into really some hardcore statistical methods, as I would use in other classes to investigate my research hypothesis, but what this data set will allow us to do is to explore some stuff. And so that you start learning how to use SAS and then eventually R. Okay, let's see here. So the first thing, let me come over here to my program. Go. I'm going to make this a little bit bigger. Okay, so, oops, wrong file. There we go, finally. Okay, so this is my serial.sas program. Again, you can download from the course website. And let's just go through this kind of as a review. So can someone tell me what this first line of code does? It's not too obvious. Talked about last time. Please feel free to speak up.
It clears the log and the results page.
Yeah, it clears the log window and also the results viewer window. DM stands for Display Manager. So then the second line, I have some options. What do they do?
How many characters are on a line?
Exactly. How many characters are in a line? Obviously, it can be confusing. You might think, okay, it's the number of lines per page, but no, it's the number of characters per line that are allowed in the results viewer. Also, I don't want page numbers. I don't want a date displayed. Next, I have some comments corresponding to what this program is doing and identifying who wrote it. One thing that I want to say about comments is that, I said you can begin any line with an asterisk and that will be a comment. Now note, you can actually put comments other places. So suppose if you see where my cursor is right now, I put a comment there. So I say this line of code does, well, whatever, end with a semicolon. So as another way that you can incorporate a comment into a program. So it can actually be on the same line. And essentially what SAS is doing is that it notices that, okay, here's my semicolon. This is actually the end of this complete statement. And so essentially then this is actually equivalent to if I would have done this. So it was on a separate line. So, if it was on 1 or 2 lines, it doesn't matter. It's that semicolon that SAS looks for to complete an entire, let's say, set of statements. That's what it looks for, is that semicolon. Then next, I have a Title I statement, and what that's going to do is the very first line of every page in the results viewer is going to have Chris Biller Static 50 written on it. Next, I'm going to read in my data set. Again, typically, my preferred way to read in data sets is to use proc import. You can use a data step, and that's what I first introduced you with earlier, but I have found proc import to typically work better. I introduced the data step way because it's a common way that many people use. So, proc import, meaning I want to bring this data set that we just saw right here. Now I showed it to you in an Excel format or file here. It's actually comma delimited. That's why there's a .csv extension on it, and Excel just simply reads those in really simple. And so I want to read that into SAS, so I can create a SAS version of a data set with it that I can do stuff with. So here's the actual physical location of where my file is located on my hard drive. So I use the data file option to specify it. I want to put it into a SAS data set called serial. Now remember, this is actually going to be a physical place on my hard drive where this information is going to be, you can say, rewritten to. Then I say my data management system is comma separated values, CSV, and if I already have a serial data set, I will replace it. The first row of in that data set was my variable name, so I say get names equal yes. My data actually starts on row 2, and then I run it. So let me go ahead and actually run all the way up to the top. First thing I always do, I check my log window to make sure everything looks okay. It says, oh yes, it was successfully created. So that gives me a good feeling. 40 observations, 7 variables, and if I go back to my data set, indeed I have 40 observations with 7 columns of information. I can then actually look at the data set a number of different ways. I can come over here, if you see where my mouse is, to the Explorer tab, and you see something called serial. So this is actually stored on my hard drive, and this is SAS's version of the data set. I can't make it any bigger than that, unfortunately, in terms of the font size, but that's my SAS data set. And just from looking at it, yeah, it looks like it worked out fine. Now, one thing I didn't show you last time that I want to make sure to show you now is that you can actually right-click on these columns. So if I right-click here, you have a little shortcut menu that comes up. You have column attributes. And a little window will come up that will tell you, for example, the name of that variable. Well, of course, it's serial. That's what you saw. But let's say I had a label with it, such as serial space name. And I can, if I want to, I can apply, close. And notice now you see serial space name there. Now, if you were to, and you saw us using Proc Print last time, if you wanted to specify, I just want to print this serial variable, you cannot say serial space name. You have to actually say serial, because that's still the regular name that you see listed in the name area there. So variables in SAS, and this is actually in the notes. It was towards the end of the class, and I unfortunately skipped over it. Variables in a SAS data set can have a name and a corresponding label to it. But when you are actually programming and you are saying, I want to print, let's say, this particular variable, you have to use the variable name, not the label. This gets a little bit more confusing later on when there will be data sets that SAS will create all on its own, and what you're going to see is only the label. And you might want to refer to a particular variable in the data set, and how do you figure out what that variable name is? Well, one main way is to do exactly what I just showed you. Again, maybe by telling you that right now, it's getting ahead of ourselves, but I thought now would be a good time to first discuss it. Also, a way to make sure that I read in my data set correctly, I do this more often when I have a large data set, and where obviously in this particular case I only have 40 observations. It's easy just to page through that data set that we just saw to make sure, yeah, everything looks okay. When I have a larger data set, what I will often do is just simply do a proc print, where I print the first 5 observations. I could print 6, I could print 10 if you want to be even more safe. I just often do the first 5. How do I do that? Proc print. We looked at proc print before. On the proc print line, there is an option called data that specifies what data do you want to print. And something that's new is that you can actually specify particular options associated with that data set. By saying obs equal 5, I want the first 5 observations to be used only with this proc print. So if I go ahead and highlight them, there you go. One place where you will often use this, at least in this class, is to prove to me that indeed you have read in the data set correctly. Do a little proc print, show me the first few observations, and that says, oh yeah, okay, you did it right. And when would you do that? Like on an assignment. Okay. There's many other little options that you can always include in parentheses right there. You know, too many for me to mention. I have an example here in the program that shows, well, maybe you only want to keep 2 of the variables when you are printing it for some reason. Okay. Now next, what I need to do with this data set is make some changes to the variables. So let's take a look at the data set once again. So is this big enough that everyone can see it? So notice how Kellogg's Razzle Dazzle Rice Krispies has serving size of 28 grams, and of those 28 grams, 10 of them are sugar. But then when we come down to here, we have Food Club Toasted Oats, 32 serving size, 2 grams of sugar. And while we, I think we all agree that Food Club Toasted Oats has less sugar content. But, suppose it was 32 was the serving size, and it was 10 sugar grams. Well, it has exactly the same number value for sugar, but one has a larger serving size than the other. So we need to adjust sugar, fat, and sodium to account for the serving size so that we can make fair comparisons between different cereals. Is everyone clear on that? Does anyone need me to talk about that? Okay. So how can I do that? Well, I can take sugar divided by serving size. That's it. Do the same thing for fat, do the same thing for sodium. Now, how can I get SAS, though, to do that? That's where a data step comes in. So we've talked about data steps primarily just in terms of being able to read in data. But anytime that you want to change a data set, the primary way that you do that in SAS is to use a data step. So I'm going to just simply type a little temporary one or example one. Suppose I create a new data set called temp through a data step. Again, a data step, first line always begins with data, Then you have the name of a new data set that you're creating. The last line always ends with run. In between the data in the run, this is where you can put other information. Now, before, what we've done is actually read in a data file from outside of SAS. Here, what I want to do is actually take a data set that I already have in SAS and do some stuff with it. Specifically, I want to do some stuff with that serial data. So to tell SAS that's how we're going to work here, I'm going to say set serial. So the set command says, okay, this new data set that I'm creating called temp is going to be based upon a data set I already have called serial. And in fact, if I were just simply to run this segment of code, all that's going to happen is that temp is going to be an exact copy of serial written to my hard drive. So if I come over here, you see something called temp, and there it is. I can do a variety of things now below that set. This is where I can actually make the modifications that I want. So for example, I can say a new variable called sugar that I'm going to create, which is going to be equal to the variable that's already in the data set called sugar underscore G. So this is the unadjusted sugar content. Divide by the serving size. And with the semicolon. And so now what's going to happen, do this, I run it, I come over here to temp. Notice this last column here is basically what I added to my data set, or I added now to this temp. So for example, 0.3571 is equal to 10 divided by 28. I can do a whole bunch of other kinds of operations too here. Suppose I want to create a variable, for the lack of a better name, called temp1. I could say sugar plus fat. You wouldn't want to do it, but you could do that. Just take sugar plus fat. I could do sugar asterisk fat to do multiplication. I could do sugar minus fat to do subtraction. Suppose I wanted to take sugar to the second power, so I wanted to square it. How do you think I would do that? So you might think it's this. It's not. Sorry, it was a trick question, but thank you for participating. It is actually a double asterisk. You see this often in older programming languages. I don't know, maybe it's before my time. Maybe a caret symbol wasn't available on the keyboard as easily. You use the double asterisk to mean to take it to a power. There are also various functions that are available to you in data data set. So, one way to do a square root, well, you could take asterisk asterisk 1 divided by 2, or you could use the sqrt function to do a square root. Many other functions that are available to you. Where would you go to find out where all these functions are, do you think? The help. Let's look at how we can find it. So I click on help. Okay, remember how SAS is divided up into different products. Does anyone remember what product a data step is in? Base. Yep. So we come over here to base, and again, it can be difficult to find what you're looking for. Let's see now. We want to go to functions and call routines. Let's see here. Dictionary of functions. And here we go. We see a whole bunch of functions that are available to you. Obviously, some are going to be a lot more meaningful than others right now. Let's see now. Aha, square root. Okay, so that's how you find. And we can't go through every single function here. That would take forever. And most of them are not going to be ever of use to you. But this is how you can find the help for a particular operation that you want to do. Now, of course, you could also use the little quick search thing up here, but at least what I have found is that there's this various functions or various names that you're looking for can be scattered about all parts of SAS, and you might see that your name then pop up in some parts of SAS that is not going to be helpful to you, not for like a data step in this case. And so that's why I think it's very important to understand the basics of the SAS products and then where to find certain things inside the SAS products, which I think in the end can be more useful. Okay. So in my actual program itself, and then also in my notes, then here's where I make those little adjustments based upon the serving size. Also, again, there's many different things that you could, many different statements that you can have. I don't need any more of that serving size. I don't need the old sugar. I don't need the old fat. So what I'm going to do is drop it from the data set. So I use a statement called drop. Let's remove it. Let's look at our new data set, which is going to be called set 1 for the lack of a better name. And there is the data set now I'm going to be working with. If I wanted to, instead of using the drop statement, I could have used the keep statement and specified the actual variables I want to keep in my data set. So drop and keep can be useful just to tidy up things at times, so you don't have too large of a data set. And again, if I wanted to make sure that I did it correctly, obviously, we already clicked on set 1 to take a look at it, but especially when you're doing assignments, it's very helpful for me to see a printed version of the data set. So I'm just going to print the first 5 observations, and you can see there's my new data set. Okay. Let's see here. So we've looked at Proc Print already to print stuff. We've looked at we've seen before that there are particular commands or statements inside of procs that you can use. In particular, we look at the var statement before, where if we just wanted to print particular variables, we can say var shelf cereal sugar, for example. Another statement that you can use that we haven't talked about that can be useful is the where statement. Where allows you to specify, I only want certain things to print. Where I'm not talking about variables anymore, I'm talking about rows. So where shelf is equal to 1, only print that. So let me go ahead and do that. And there you can see I'm printing just 3 of the variables and only shelf equal 1. The var statement, the where statement are in most SAS procedures. That's one reason why I introduced this to you now. And they have often a very similar meaning in those other procedures. Again, there's a number of different options of what you can do with Proc Print on the Proc Print line, and this is the same is true for other SAS procedures too. How do you know which options are available to you? That's where again you look at the help. As an example, one option, we have no obs, meaning don't print the observation numbers. So it was just more of a thing to make it look nicer. Notice how there was no observation numbers printed, where previously there was an obs column always given by default. That where statement can be quite powerful. Let's say if you want to look at just shelf equal 1 and low sugar content cereals. You could combine shelf equal 1 and sugar, let's say less than 0.1, with an and statement. There's also an or option as well that you could use, depending upon what your desire is. And also, and this can be kind of confusing, especially to new SAS users. Maybe I shouldn't tell you this, but I'm going to tell you it anyway, not to confuse you. But you can actually bring that where statement up into as an option for the data set. Remember how we saw that? Where was that? up here for odds equal 5. Well, guess what? You have that same kind of terminology with respect to where that can be used as an option. Oops. Right up there too. Yes.
Can you do like more than one of those options, like do parentheses, like odds equals 5, and then parentheses where shelf equals 1 and sugar?
Yeah, you don't need a parentheses to separate them,
Okay.
but you can do that. You just need a space. The key is that since this where has multiple components to it, and also notice that you have that equal sign there, which can be kind of confusing with that equal sign there. When you have that equal within an equal, essentially, that's why I needed to put a parentheses inside there. And maybe that's what the parentheses you're talking about. Maybe you're talking about this parentheses. Hopefully it's correct.
Okay, I understand.
Okay. Now another SAS procedure that can be very useful is called proc sort, which simply allows you to sort your observations. In other words, the rows of your data set by particular variables. Some SAS procedures will require you to sort the data a certain way first, depending upon what you want to do with the SAS procedure. Sort the data first before you use that SAS procedure. So simply, as you might expect, if I do proc sort, option with a data equals set 1, it's going to sort the rows by first shelf, then sugar. So if I do that, now what happens is that set 1 is actually going to be readjusted so that things are sorted. Notice nothing went to my results viewer because I didn't ask for anything to go to my results viewer. Instead, if we come back over here to set 1, you're going to see if we look at just shelf 1, notice I have a low sugar for observation 1. The last observation in shelf 1 has the highest sugar. So I was shorting sugar within the shelf. Okay, any questions? So at the very end of these lecture notes then, I just show you a little bit about, well, how do I use SAS in terms of my, on my computer? And typically what I do, which I won't do here in class because we have limited amount of space here on the screen, I use usually a larger font, is, and this is a screen capture, I know it's small, but what I do is I try to arrange my windows within SAS so I can see my program on the left and then my output on the right. The reason why I do that is so that I don't have to keep on flipping back and forth between my program and my results viewer. It's just inefficient to have to do that. Now actually at my desk, well, my desk here on campus, I actually have, if you ever come by my office, you'll see this. I have my monitor set up in a portrait manner because it's easier to read, and so I actually have my program on top, and then my results viewer on the bottom, which is my personal preference. Okay, are there any questions? Okay, let's move on to the next set of notes then. Okay, so these set of notes are going to introduce you to two new SAS procs. Proc means, and as you might expect, it allows you to calculate means, but it does a little bit more as well. And also proc reg, reg standing for regression. So we'll do a simple regression model. I think this is a good place to introduce these because these procedures then contain a lot of the same kinds of syntax that you're going to see in other procedures. So while the actual calculations are simple, again, this is to get you going so that, especially beyond this class, you're able to use these SAS, any kind of SAS procedure that you get, the basic syntax that's going to probably be used with that SAS procedure. I have a new set of programs that are going to be associated with this section here. So please be aware of that. So even though we will be using the serial data and the GPA data, again, will be different programs. Okay, so first of all, let's talk about proc means. So this is in base SAS, and this is just a simple screen capture from the help for procmeans. So as you might expect, we have procmeans at the very beginning, and similar to what we've had before, we have some options after it. One particular option, as you might expect, is data. So you can specify what data you want to use when you're using procmeans here. We also have an option called statistic keywords. What this is going to allow you to do is specify particular statistics that you want, like a mean, but you can also specify a standard deviation, you can specify a percentile, you can specify you want the median, and there are keywords associated with it, so you can say, so that SAS knows, oh, you want to calculate that. Similar also to what we've seen before, we have a var statement as well. This tells SAS what variables you want to use with procmeans. We will also be looking at a class statement and a by statement as well. Both of them basically allow you to do these computations within groups. So if I say, as you'll see shortly, class shelf for that serial data, it will do my statistical calculations for each shelf individually. The by statement does that as well. The main difference, at least with procmeans, is that it just organizes the output differently. That's all. By and class will have somewhat different meanings and sometimes in other SAS procedures. But the main thing, though, is it's a way to specify how your data is grouped. Another new statement that we're going to look at is output. What this says is that, after you do these calculations, you have it printed to the screen. Very often, you want that stuff that's printed to the screen essentially to be saved for you in a new data set. The output statement tells SAS to do that, where you specify out equal for the particular new data set, SAS data set that you're creating. Okay, so let's take a look at an example, again with the serial data. So in my notes, I have essentially the same stuff that we've done before, just as kind of a reminder. That, okay, this is how I got to where I need to be. I do the adjustments to the data set. And let me go ahead and go back over here to SAS. Okay. So here's my first use of procmeans. Procmeans data equals set 1. So again, the data is my option. Set 1 is the adjusted serial data. I want to do calculations based upon the variables sugar, fat, and sodium. And I want some results that are put into a new data set, which I call out_set1 for the lack of a better name. So when I run this segment of code, this is what I get. I essentially get the default statistics that would always be printed. I should say always. The default statistics that will be printed. So we can see the mean for sugar, the mean for fat, the mean for sodium across all observations, all 40. So n corresponds to how many observations you have. And we have standard deviation, the minimum value, maximum value. Now remember there was a data set created too. If we look at the log window here, you'll see, okay, there were 40 observations that were read in that were used for procmeans. A new data set was created with 5 observations and 6 variables. And if we look at outset 1 here, this is what was created, essentially the same information that we saw printed to my screen. So if for some reason I needed to do some additional calculations later with this information, I could. Again, we have looked at an example where that will occur, but in the assignment coming up, you will get to do that. I think you will. I know there will be other assignments you will. And other times in the semester where we will. Okay, now let's run procmeans again, but now I'm going to add the class statement. So class shelf. What that's going to do is do these same calculations, these default calculations now within each of the groups. So now we see exactly the same thing as before, but it's broken up by groups. So let's focus on sugar. If you can't read that, at least you can't read it in the notes. Look at the sample means for the different shells. Is there at least maybe some empirical evidence here that my research hypothesis might be true? That higher sugar content cereals are on the lower shelves? At least for shelf 2, yeah. And again, if you think of Callum at that grocery store, his eye level was actually at shelf 2, where you're numbering from bottom up. So shelf 2 is the second from the bottom. Obviously, we're not making formal statistical conclusions here, but we're starting to see some evidence of maybe that my research hypothesis might be correct. Now, if I were to do the same set of code, but instead of using a class, I use a by. You can take a look at what happens. Now you just see the output organized differently. That's all. Okay. Okay, I have a little note in my notes here, handwritten note here. Show you something. Okay, now let's go back to this outset 1 again. So this was created with the first Proc Print. Sorry, I didn't do this before. Notice how you have some variables called underscore type underscore freq, F-R-E-Q, and then underscore stat underscore. These are SAS created names. So whenever you see SAS created name, you'll see often underscores with them. Just a little note there. Okay.
Is there a way to change the name or just the label?
You can change the name. I mean, we could actually do it manually by right-clicking on it, column attributes, or actually, no, you can't there. I apologize. How would you change the name? Well, let's go ahead and do it. So let's say data temp set outset 1, rename stat equal, we'll call it. And there you can see how it's been renamed. So there's a renames option as well. Every once in a while it can come in handy to do that, especially for just keeping everything straight. And so you can use the rename statement for that. Okay, let's see. Well, what would happen? So let's do this procmeans here. So class shelf, I have my 3 variables again, and then I am doing then the output there. So I'm going to put some information into this new data set. One thing that's new is I've included, remember in the help we saw statistics keywords? Well, here are some possible keywords. Again, there's a lot of them. I can't show them all to you. Where would you find them? Go into the help. But here's some examples. The mean, alpha equal 0.05. What do you think that's going to be used for? I'm going to do some inference. So hypothesis test, confidence intervals. I'm actually going to do confidence intervals. So CLM stands for confidence limit mean. I have a median. What do you think P50 stands for? Percentile 50. That's what that corresponds to. So you could actually use P40. P21. You could do that. Okay? Then STD, unfortunately, they use that abbreviation there. That actually stands for standard deviation. Yes?
Does the order matter for that stuff?
No, the order doesn't matter. And thank you for bringing that up. That's something else I wanted to mention, is that you can put this stuff in any order that you want, essentially. I usually have a particular order, and that's what I tend to follow here. But you can actually get away with mixing the order there. So let's go ahead and run this and see what happens. So we no longer have the default that we were seeing before of the sample size, the mean, the max, and also the min printed. Now we have just what we've essentially specified printed. Since we use class shelf, we have everything organized by shelf. So we were looking before previously with respect to this sugar content. It's 95% confidence interval for the mean. For the true mean is 0.35 to 0.48 about. Compare that to some of the other shelves there. Notice you do not see an overlap between the confidence intervals. While this isn't necessarily the most appropriate way to find differences among means, this is kind of an ad hoc way to say if the two confidence intervals don't overlap. Well, I'm saying the true mean is over here, the true mean is over there. Oh, maybe there is a difference in the true means for those two shelves. You know, you could use ANOVA methods to make a more to reach a better conclusion, but this is kind of an ad hoc way here to see that, hey, we're seeing some separation. We also see some stuff going on with respect to, which one was this? I think it's the sodium. Yeah, look at shelf 1 for sodium compared to the other shelves. I have never been able to figure out why would the lower shelves have higher sodium content than other shelves. Now, at least I always associate sugar with kids and stuff. Maybe I'm missing something. So anyway, so that's some of the stuff that we have here. Now let's take a look at the corresponding data set that was generated, outset 1. Well, it's not exactly like what we were having before. The reason because we have the class statement. So that class statement forces all the computations to be done by shelf. And notice, and I wish SAS would do this, notice the first 5 rows, that actually corresponds to across all shelves. Even though I didn't want that, it automatically puts that information in there. And how do I know it's all across all shelves? Look at the underscore freak underscore. It says 40. Frequency. How many observations were there? 40. But notice we have, again, just simply the default of what we were having before. We have the min, max, mean, standard deviation, and the sample size. Not what we have specified up here. Why? Well, what actually specifies up there only goes to what's printed to the results viewer. If I want particular statistics to be put into this output data set, I have to actually specify those statistics. Here's how you do it. So if we just look at this first output here, so I'm going to create a new data set called out_set2, and here are the key words. Mean. I'm going to put the sample mean into outset2, and for the lack of a better name, the new variable that's going to be created is going to be called mean as well. So the first word is what SAS looks at to know what statistic you want. After the equal symbol is what you want to call it in the data set. Next, LCLM, lower confidence limit mean. I'm going to call this variable in my data set lower. I do a similar thing with the upper. Well, what's the confidence level that's going to be used? Well, SAS goes back up to here in what you specify for alpha. So 95%. Now, what will happen here, we'll go ahead and run this. This is what I get for that outset 2 now. Now remember, what were the variables that we were looking at? Sugar, fat, and sodium. But I only see information for I don't know what. And actually, I think we even had that before, and I failed to mention. I apologize. No, we did. Okay. But I don't have anything. I don't know. Is this sugar? Is this fat or sodium? Well, just from looking at that, if you remember what we had before, you can figure it out. It's sugar. And so what SAS does, it takes your first variable that you're specifying in the var statement, and that's what it puts in there, the corresponding information for that first variable. Well, how could you get the second variable? How could you get the third variable? Well, take a look at this second output statement. And yes, you can have more than one output statement in a procedure. And when I say mean parentheses sodium in parentheses, that says, okay, now do the mean for the variable sodium. So that's how you specify a particular variable. So what I would like you to do on your own is look at the corresponding data sets that are created by using these output statements, so you can get a better feel for how you can create certain things from these data sets. This last one here corresponds to a nice little option. Notice how I'm not necessarily saying sodium, sugar, or anything like that. Whenever you see a slash like this, and you will see this a lot in SAS, many statements allow you to do various options with them, and they always occur after a slash. So when I say auto name there, what's going to happen is it's actually going to create a data set that has like the mean, confidence interval limits for all three variables, and it's going to automatically create names for them. Run the code, you'll see what I mean. Okay, so that takes us to the end of Intro to Proc Means. Are there any questions? Okay, next what I like to do for, I guess, the extra part of this class that we have available to us is start discussing the assignments. So if you have a copy of the assignment, please take it out. Okay. So there's two problems with the assignment. We're just going to talk about the first one today because it involves doing stuff like what proc means. The second problem involves using this proc reg to do a regression model. So we'll save that for next time. Okay. So again, you can work in pairs. If you do work in pairs, please only turn in one assignment per group. When you turn it in, you're actually emailing it to me. When you email it to me, the file name of what you're turning in should be the same as the names of the people who are in that group. Okay, so put both people's names in as the file name. I do not want to see, maybe 8 assignments emailed to me that all have an attached file called assignment1_web.docx. Because when I put it into a folder, that means I have to manually myself change the name of that files to correspond to, so that one file doesn't write over the other file. Okay, so so complete these problems. Within each part, make sure you include all your SAS program code that was used to get to your answer. Also, include the corresponding output as well. And there will be at times additional information that you might need to include, such as maybe some kind of a typed answer. We will go through an example of exactly what to include shortly. I will actually do problem 1A for you. The key thing is that your SAS code and output should be formatted in a very similar way to my lecture notes. So in terms of, for example, like parts of your code should be nicely indented. Okay, so this first problem deals with the National Football League. Don't worry if you don't know much about football. That doesn't really matter. You can do very well here without knowing anything about football. When choosing data sets for assignments in this class or any class, I try to choose data sets that generally a large number of students will have some knowledge about or even some interest in. And there's never going to be a data set that I choose that everyone's going to know the context for what the data means. And so that's just what happens. And so anyway. Okay, so this deals with something with regards to the National Football League called the Scouting Combine. So every year during the spring, college football players who want to play professional football, they are evaluated by professional football teams in terms of like their speed, how high they can jump, how strong they are. They're evaluated so that these teams can get an idea of, well, who's better than who's the best, or is this player better than another player. And then once they get that information, then they have what's called a draft. I think it's in April every year, maybe it's May, where these teams will select college players that they want to play for them in the following season. If you want to know more information about that, there's some web links. And so I have this data set. It's a comma delimited file that you can download from the Graded Materials webpage of the course website of information that was collected during the 2014 college or the Scouting Combine. And this is what the data set looks like. Let's see here. Give me a second. So we have information regarding the player, the college that they played for, their position. Don't worry if you don't know what these positions actually mean in the context of football. Just realize that we have categories. People fit into categories. Like kind of like the shelves in the serial data set. Now we have positions that every player fits into. A listing of the actual positions is located on page 1 of the assignment. So for example, WO means a wide receiver. And what we're going to be concentrating on for this particular assignment is their 40-yard dash time. So for example, this first player here, Jared, he runs the 40-yard dash in 4.5 seconds at the combine. Also, we're going to be looking at the bench press. How many times can they lift 225 pounds? This player is kind of weak relative to other players, and he can only put up 225 4 times. I can do about 8 or 10. But anyway, so maybe I can play this up. Anyway, though, so we have a lot of players listed here. Let's see, how many do we have? About 130. So, it's a decent-sized data set. Obviously, it's not big data, but it gives us some data that we can explore in further detail. So let's look. Using this data set then, let's complete the following problems. So part A, read the data into SAS using Proc import and print the first 5 observations using Proc Print. So this is what I discussed earlier, that Proc Print there helps me see that yes, indeed, you have read in the data set correctly. So we're going to actually do this problem. So when you actually do this yourself, what I recommend that you do is, of course, you download this Word file from my course website, and you just simply answer the questions inside the Word file itself. Don't retype it. Just use this file here, put a big space in there, and this is where you can insert your answer. So let me go over here to SAS. So what I've done before class is I've typed up what the corresponding code would be to answer this problem. And again, for every program to start off with, I want to clear my log in Results Viewer. I want to add some options as well. I have some nice comments there. I have a title that's going to be at the top of every page of my output. And now I read it in. This code that I use to read it in, where do I get this from? Basically, I copy and pasted my code from that serial data program and made some modifications to it. such as what was the name of the corresponding, move over, maybe I can't, what's the name of the corresponding data file. It's a comma delimited file just like that serial data. So I read it in, and then I use Proc Print to print it off. So let me go ahead and run this code. Okay. Notice I had a little error message. Does anyone know why I have that error message? SAS can be picky when you have that file open in Excel already. I think it's kind of poor that SAS does that, but it's just what happens. So I close it out. Oops, wrong program. And I'm going to rerun that. I have my data printed. There's my log file. Looks like things are going good. If I come over here, so what did I call it? Shoot. I call it NFL1, and there's my data. I can page through it if I want to just to verify. If you ever see a period as a variable value, that's what SAS uses to mean it's missing data. So that's very important because, and let me emphasize this, you should write this down because something I noticed that's not in my notes. A period as a data value in SAS means missing information, a missing point. That's why it's a period. So if I started seeing a bunch of periods there, if I didn't have any concept of what my data actually was, if I had a bunch of periods there, that would make me concerned if maybe I didn't read my data correctly. So things look good. So now what would I turn in then to answer this question? Well, in order to get to where I needed to print that data, I needed to execute all this code. So I'm going to copy this code over to my Word file. Oops. Oh, you don't need to see that. That was the enter key. I copied over to my Word file. I nicely format it. So I'm going to bring this over so it's obviously indented under Part A. And there's usually a few things I need to clean up. So I'm going to clean this up here. Clean that up there. I would keep on cleaning some stuff there. Notice how things are not nicely arranged as they were before. So I'm just going to move some stuff, and it doesn't really matter the exact directory on your hard drive where you locate stuff, so I'm just going to move that. And I'm just trying to make it look nice and professional looking. I'm going to move that run over. For some reason, sometimes when SAS copies stuff, the indenting gets screwed up. And there's my code. Now I need to also turn in my output. There's a few different ways to do it. My preference would be to do a simple screen capture. What do I mean by that? Well, in terms of, let's say, using a Windows-based computer, I can come down to, if you see where my mouse is, come down to the snipping tool, click on New, and copy it. Now, obviously, in this particular case, I have a lot of variables, so I can't capture everything. So I'm going to just copy that. And paste it. So all my lecture notes, if you've noticed, are screen captures, just like that. Now what some people will do, and I don't think this is good, I can simply highlight this all, copy, come over to Word, and paste it. Now, which do you think looks better? That or that? Well, the top I think looks a little bit better. You know, maybe you could format this a little bit better to make it look nice. But at least my preference And it obviously depends upon how much output that you have actually displayed. But my preference is typically to do those screen captures. It's up to you what you want to do. It just needs to all look nice and professional. Now for this particular problem then, this is all I need to do. But there might, maybe there was some other part here in this problem where, it said, interpret the results, or do a hypothesis test, or state the regression model. If that was there, I would actually need to do some typing myself, where I would need to follow up with what was given in the code and the output, and actually do the hypothesis test. Like state the hypotheses, state the test statistics, state the p-value, develop a conclusion. Don't just think just because, let's say, the p-values in the output, that's enough. As a professor, how am I supposed to know where to look? Or that you actually know where to look yourself to find the necessary information. So there will be times where you need to follow up with additional typed text. Okay. Any questions in terms of what my expectations are for what you would turn in for a particular problem? Okay, let's move on then. So let's look at part B. So B says, well, sort the players. Well, of course, we looked at proc sort today. Sort the players by position. I'm sorry, by their 40-yard dash times. And then simply print only the names of each offensive lineman with their 40-yard dash times. So, proc sorts, proc print. What other statement in proc print is going to probably be helpful here? So that you only get the offensive lineman. Where? Okay. So, get the code, get the output, copy both into here. There wouldn't be any additional stuff that you would need to do beyond that. Part C, find the mean 40-yard dash times for the players by each position. So what procedure? Proc means with a class statement. Then I have some follow-up questions. Which position has the fastest players on average? Well, this is where you're going to say, the position with the fastest players on average is, type it out. Part D, using proc means, find the mean standard deviation sample size for the 40-yard dash time. So you're going to probably be using some statistic keywords now with proc means. And do this for the offensive linemen and wide receivers. Do it both separately. So I want offensive linemen, the information. I want the wide receivers as well. And then export this information to a data set. I want you to do it one of two ways, using output statement that we talked about today, and then what we will talk about next time using what's called an ODS statement. And then lastly for this problem, or not lastly yet, part E, notice there's a little bit of a small typo. I use a subscript WR in the notes. That should be a WO instead. And what this means is I want you to do a t-test. I want you to compare the mean 40-yard dash time for offensive linemen to wide receivers. So difference of means. Do a formal hypothesis test. You can get, and this also, let's make sure, as 2 sample t-tests with unequal variances. All of you should have seen that in another stat course before. If not, come talk to me afterwards and I can explain what that means. But I want you to actually do the t-tests, where you can use SAS to get the necessary, let's say, sample means, the sample standard deviations, and obviously the sample sizes. But from there, I want you to actually type it up. Include the necessary equation for the test statistic. Include the necessary equations for the p-value. Do this all, you could say, by hand. I want you to do it that way first. And then in part F, you're going to look at a new procedure we haven't looked at yet called Proc T-test that will automatically essentially do the calculations for you. And why am I having you do it two different ways? Well, very often when we do stuff, let's say, by hand first to verify what the computer is doing is correct, or to have a better understanding what that computer does. So in the end, you know what the correct answer should be for the actual test statistic, or you should, based upon what Proc T-test is going to give you. But I want you to make sure that you can go through the actual steps. So we haven't talked about Proc T-test, and I've done this on purpose because, you know, one of the main aspects of this class is that you need to be able to take what you learn here for some procedures and apply it to new procedures. How do you know how to use that new procedure? Look in the help. The syntax will be very similar to what we've seen, like for example for procmeans or some of the other procedures that we'll look at. But this will give you an idea of now going beyond what I've talked about in this class and applying it to essentially a new problem. So with this Proc T-test here, show me that you can get to the help page that shows the syntax, perform the calculations using Proc T-tests, and then this other stuff will be clear after we do this stuff called ODS next time. Again, problem number 2 deals with regression modeling, so we'll save that for next time as well. Are there any questions regarding this assignment so far? Okay, that is all for today.